Hello, my name is Andrew Mattson, and this is my presentation on evaluating the Raspberry Pi Pico 2 as a modern replacement for the Arduino Nano. So why specifically these two chips? Well, the Nano has been around for a long time. It's a staple in many embedded systems, including the systems we run at the Aurora Robotics Lab. We use Nanos to control the motors on our robot. But since the Nano has come out, the Pi Pico 2 has come out, and it offers some more enhanced features. So my objective for this presentation is to evaluate the Pico 2 and see if it can serve as a potential modern replacement for the Nano. Architecturally, there are some pretty major differences between the two. The Nano runs off of the Atmega 328. That /P is because nowadays the Nano runs on the 328P. That P stands for Pico power, which has nothing to do with the Pi Pico 2, but means that it includes optimizations for lower power consumption. It runs at a 16 MHz clock speed and is only single core. We can compare that to the Pi Pico 2, which has 32-bit architecture, dual core ARM and RISC-V support, and up to 150 MHz clock speed. That dual core is massive in most applications, especially those that are time sensitive, like robotics. Being able to handle multiple tasks at the same time, and with that higher clock speed, just gives us so much more we can do. So as far as performance, we talked about the clock speed already. The Pi Pico 2 is almost 10 times faster. As far as MIPS, the Nano only gets 1 MIPS per megahertz, so around 16 MIPS, whereas the Pico 2 ends up with 300 because there are 2 cores and 2 MIPS per megahertz, so that's close to 20 times. Floating point hardware is not present on the Nano. This is something that is massive for especially robotics applications, but also every other application as well. The Pi Pico 2 has this hardware, and that gives it much quicker processing for floating point operations, which make up the core of most applications. Something similar to the previous slides occurs here with memory. The Arduino Nano only has 32 kilobytes of flash, 2 kilobytes of SRAM, and only a kilobyte of EEPROM. The Raspberry Pi Pico 2, on the other hand, has 4 megabytes of QSPI flash. QSPI just means better speed and data width because it uses 4 data lines instead of 1, like the Nano. And on top of all of that, the Pi Pico 2 has external memory support. We can add up to 16 megabytes of PSRAM. That extends our capabilities even further. As far as I/O capabilities, the Arduino Nano is very limited. The Raspberry Pi Pico 2, on the other hand, is far more versatile, and as you can see, the Nano only has 14 digital pins, 6 PWM channels, and 8 analog inputs, whereas the Pi Pico 2 has 26 GPIO pins, 24 PWM channels, and 12 PIO state machines, as well as USB 1.1 support. USB is actually the communication protocol we use across the robot to talk to our Nanos via serial. So if we could just talk by just straight USB, that is a huge improvement. Here we have the I/O structure of the Nano. On the left, you can see the A pins are the analog inputs I was mentioning earlier, and the D on the right are the digital. Sort of limited here in what we can accomplish, because there's not, it's older, like I said, newer stuff isn't supported as well. On the other hand, the Pi Pico 2, far more modern, far more capable, despite a very similar chip size. As far as development environments, the Arduino Nano is pretty limited to the Arduino IDE, and that only supports C and C++, whereas the Raspberry Pi Pico 2 supports C and C++ as well, but also MicroPython. That allows for very fast prototyping when you combine it with the drag-and-drop programming via USB. It also has extensive documentation. The Nano's been around for a long time, so it's very well documented, but the Pi Pico 2 doesn't seem to be lacking in that field at all. As far as cost and availability goes, The Nano, if you go for the name brand model, can run you about $8. If you go for the clones, you can get them for around $2. The manufacturer of the Atmega 328P has actually marked the chip as not recommended for new designs. They're trying to phase it out. Whereas the Pi Pico 2, very similar price point at around $5 a chip. The chip, or rather per microcontroller, the chip itself is priced only from 80 cents to $1.30 from what I could find, and that means that it's very cheap and easy to use on your own custom chips as well. The availability of the Pico 2 is also assured until at least 2040. So that just means, like you can see with they're trying to phase out the Atmega 328P, and so the Pi Pico 2 seems to be the way into the future. So in conclusion, if it wasn't clear, the Pico 2 is significantly faster, has much more memory, much more expansive I/O, and peripheral support overall, with USB support. It has those 2 cores, which makes for just many more applications you can apply it to. It has more modern development tools, better availability long term, and lower cost if you don't consider the clones. So in conclusion, the Raspberry Pi Pico 2 is clearly an upgrade over the Nano in every category. It's future-proof and much more performant. It'll serve very well as a replacement for the Nano. Here are my references. I got my chip architecture data sheets from those 2 sources for the Arduino Nano and the Pi Pico 2. I also got more data sheets and documentation from those sources. I got my benchmarks from this website. Those the comparison of the performance. And I also looked into, for a lot of the discourse, the academic literature on this as well, from both IEEE and ACM sources. So thank you for watching, and I hope you have a great day.